Hello and welcome. I'm Matthew, and this video is the first in a series on installing the MVS 3.8 operating system from scratch under a Hercules-emulated S370 mainframe. Now, why in the world would we want to do that? I suspect if you're asking that question, perhaps this video series isn't for you. It's mostly just about fun and learning for the sake of fun and learning. For some of us, this sort of thing is fun. In any case, many of us have been happily playing with the Turnkey systems, whether that's the Turnkey 4- system or the Turnkey 3 system before that. And these systems really provide a great way to get up and running quickly with our own system. Clearly, a huge amount of work has gone into customizing these systems, adding additional software and configuration. There are some great communities around these systems on the mailing lists, on the Moshik's mainframe channel, and his Discord. And this is how I learned everything I know about the MVS operating system and really IBM mainframes. I started with TK3 back in, I think it was about the year 2000 or 2001. And I had never used a mainframe before. I didn't really know what they were, what operating systems they ran, how they were different from just the Unix-like systems I had used, from VMS, from some older operating systems. They're certainly a unique and challenging world of their own. And these turnkey systems let you just download a software package and fire up your very own private, complete emulated mainframe running the MVS operating system. And this operating system, MVS 3.8, is a direct predecessor in the line of operating systems that leads up to the current ZOS that still runs on current IBM mainframes, which IBM is still making and releasing new hardware models every couple of years. So much of what we learn about the mainframe from the turnkey systems running MVS is pretty directly applicable to systems that are out there in the real world today, running the back end of a lot of banks and other companies that are still using their mainframes. So in any case, I was curious how such a system comes together. You know, what would it look like to get a new S370 system at, say, 1980, and turn it into a working, productive system running MVS like we have on these turnkey distributions. And I found that running through an installation, or a Sysgen, as a lot of the mainframers call it, although that's technically just one step that we'll see in the process, running through those installations several times has taught me quite a bit more about how the system works. And in the end, I really find it quite rewarding to work on my own generated system, not because it's any better than the turnkey systems in any way, but because I really have a much better understanding now about where everything is, why it's there, and what is on the system. It's not just a big black box with a lot of complicated stuff inside of it that I can really only, poke at and see what happens. It's something where I feel like over doing this many times and reading the JCL scripts that put this together that we'll see, starting to understand what each of those steps is doing, it really feels much more like a system that I can wrap my head around. And when I want to change something or do something on it, I know where to start. And of course, all of that then applies back to the turnkey systems. When I use the turnkey system now, I get why it is the way it is. I understand where the different pieces of it are coming from and how they work together. And how the whole system's put together. So if you're into these old mainframes, the turnkey systems, I'd encourage you to give this a try. You can run through the instructions just step by step and just see how it works. Run through it again. Maybe the third time you go through this, you start deciding that you want to try tweaking a few things, making some of your own customizations. It's an interesting process to go through, and it's fun to play with. So with that, as you can see, we'll be following Jay Mosley's instructions, which provide detailed step-by-step instructions here, as well as clear explanations really along the way about what's happening in each step, the decisions that he made that went behind how some of this is put together. And I've been installing MVS systems using a couple generations of these instructions, and the work that Jay has done is really a wonderful resource for the Hercules community. Certainly want to acknowledge and thank him for all the work he's put into this over the years. And we'll be making some modifications along the way as I walk through how I build the system. But by and large, it's really just using the material that Jay has gathered and put together, all the scripts that he's written and collated and collected from the community. And this is very much just really a video series about me following along with Jay's work here. And he really deserves full credit for everything that we're about to see here. Now, if you're not familiar with Jay Mosley's site, it's really an incredible resource for the Hercules community. If you go to Hercules here, we have not only the installation instructions for MVS 3.8 that will follow, but he really has just a ton of information on some different languages, on assembling, on the utilities. The version of the operating system we have doesn't have the VSAM libraries for COBOL, and he put together VSAM libraries. So really a great resource. Here it is, VSAM for COBOL, VSAM for PL1, for some of these really old versions of the compilers that are available to us. Great information about VSAM in general, if you have no idea what VSAM is, about the access methods. The frequently asked questions is worth the price of admission alone. Luckily, the price of admission is free, but even if not, this is probably a resource that I would pay for just because it's helped me out so many times. Things that I forget because I don't do frequently, or if I run into a particular problem or have a question, this is one of the first places I go when it comes to how these MVS systems work. So definitely jmosley.com, bookmark the site. You will find it invaluable. But today we're just looking at one piece of it, installing MVS 3.8. So with that, let's dive in. A little orientation to how these videos are going to work. I'm going to keep a web browser on one screen here, and then we'll also flip over to the terminal window where we're doing the actual work. So it's, hopefully not too disorienting. It's pretty obvious when we're in the web browser, and then when we flip over to the terminal window. We're also going to need several terminal windows open. We'll get to the point where we have Hercules itself running that we'll need to interact with. We'll have the operator's console for MVS up. We'll need a Unix shell to do some work. And so since we don't want to try and cram too many little windows in this video size window here, I'm going to have just one terminal open. And I'll use the screen terminal multiplexer so that we can have several terminals that we can flip between. Now, to try and keep us oriented, I'm going to name each of the terminals as I open it. So you can think of each of these as a different tab in this terminal emulator. And we'll name them, and then you can always see down here as I switch between them which particular terminal or tab we're in. So we have the shell, which is just our Linux shell. We might have one called Hercules when we're running Hercules. We might have one called MVS console for the MVS operator's console. So in later videos, in later parts of the series, you'll see that in more detail. But for this video, we're just doing some preliminary work to prepare our environment, and we'll just need one shell here. So I have a freshly installed Debian 10 virtual machine. That's what we're working on here. It's called Hercules. This also works fine on Debian 9, really any other Linux distribution or even a Windows system if that's what you're stuck with. But one particularly nice thing about Debian is that it has a suitable version of Hercules and the C3270 terminal emulator in its standard package repository. So we'll just be able to install those packages and we'll be up and running. I found the Hercules 3.13 package in Debian to be fast and stable, and since we don't need any of the newer features from Hercules 4, which you may also hear referred to as Hyperion, we don't need any of the features from that newer Hyperion line for what we're doing with MVS 3.8, so the Debian Hercules packages will work quite well for us. So to prepare this environment, like I said, this is basically just a fresh, newly installed Debian 10 system. We'll install some of the software we'll need. We need the Hercules emulator. This is what makes the whole thing work. Hercules is the software that emulates an IBM mainframe. And we'll need unrar for some of the packages that we get. Unzip will be handy, perhaps if we don't already have that. We want the C3270 emulator. This emulates the 3270 line of display stations that IBM made. This will be our main window into the mainframe. We won't use it at the very early steps. We'll be simulating a kind of line-oriented printer keyboard device. But once the system is up and running, we'll use the screen-oriented 3270 display station. So I think that's all we need. We'll need Hercules, a way to unzip the things, and C3270. So let's install those packages, or whichever ones aren't already installed. I'll pull in a couple dependencies. And now we have our package installed. So if we just run Hercules now, we verify it starts up, but there's no configuration file. We haven't made any emulated disks or anything, so it just shuts down immediately. But that verifies that we do in fact have Hercules installed. Now I'm going to make a directory called MVS, and everything for our system will live in this directory. Furthermore, I'll make a downloads directory just so I have somewhere to store anything that we download from the internet that we use to build our system. So flipping back over to the web browser, I really recommend that you read all this background material. Again, we're going to skip reading through the text line by line in the video just for the sake of making these videos not run forever. But there's a lot of good information here about how this came to be, a little bit of the history of this operating system becoming available to us for free. This was the last version of the operating system that IBM did not assert copyright on, as far as people can tell. And this was at the time that if you didn't assert copyright, it wasn't copyrighted, unlike today where it just automatically happens. That's my non-lawyer understanding of things. You can read more of the history on that if you want. So step one, gathering prerequisite materials. That's what we'll start with. So we already installed Hercules. If you don't have Hercules installed, if you're not on Debian like I am, and it's just not a matter of apt-get install Hercules, there's some information here about where to go to download it. You can see here that these instructions were with Hercules 3.13, which is what I'm using. It's what Debian packages. But there are reports that the newer SDL Hyperion Hercules 4 from David Trout also works. Although I have not done this complete process on Hyperion, neither has Jay Mosley, but the note here is that there are community reports that it has worked just fine. And it should, because, again, we're emulating a pretty old mainframe. There's nothing bleeding edge here. And the Hercules distributions that are coming out are reasonably stable. So we have our mainframe. IBM would have shipped us tapes. These tapes would be a starter system. This would be essentially the boot disk we would use to install onto our new empty mainframe, as well as the distribution tapes. So this is the actual MVS 3.8 software that we will install onto our mainframe. So Jay has gathered both of these. So let's copy that link, and back in my terminal, I can wget that archive, maybe. Oh, you know what? There we go. That'll work. My normal key binding is not working under screen, but that's all right. Okay, so I got the starter system tapes, and we can grab the distribution tapes. Perfect. And then really, and this is where the huge amount of work that Jay Mosley and the community that he's worked with to put this together went in, is his install MVS package. We'll look at this in a minute, but really this has all the job streams, so all of the JCL to actually do the work, the Hercules configuration files for various stages of the build, some extra tape images. These include things like the program temporary fixes or the patches that have been gathered by the community, as well as a couple other things. So that's the last big piece we need to download here. So we will grab that. Okay, so as you can see in our downloads directory, I have the tapes as well as this install MVS package. So back in my MVS directory, if we look at the table of contents for that install MVS package, you can see that it will make several directories just right in whatever directory I extracted in. So it's not going to create a subdirectory with everything under it. But in this case, I want everything in my MVS directory. So we will just go ahead and extract all of that here. And so you can see we have a number of directories. Those tapes we're going to extract into the tape directory. Those, if you remember, we can look back at the downloads. Those are in the rar format. So I'll just use that unrar command we installed. I'm going to use the E flag here for extract. As opposed to X, the E flag does not maintain any directory structure information. And I think one of these did have a directory called tape with the tapes inside, and one of them didn't. But when we use E, we don't need to worry about it. All the files will just go into this tape directory. So we can unrar our MVS 3.8. Oops, they're not in this directory. They're in my downloads directory. MVS 3.8 disk tapes. And unrar E downloads VS2 start tapes. All right, so we have the tapes that we just extracted. You can see some of these other tapes came from J. Mosley's install MVS package. So that's everything we need. Now looking at the files in this directory, you can see that we have a couple of utility scripts that are J built in both Perl and Rex. I don't have Rex installed on the system, so the Perl scripts will work for us. Personally, I like to keep things clean, so I'm just going to delete those Rex scripts because I don't plan on using them. We also have both Windows and Linux scripts for this create DadsD utility script. Well, this isn't Windows, so let's get rid of that batch file. We'll use the netcat command later to send our card images, our JCL streams into the system. Netcat is provided in this bundle for Windows users because Windows doesn't come with netcat, but we do not need that AEXE, nor would we be able to run it even if we wanted to. And netcat is a standard utility on most Linux systems, so it already came with Debian. Similarly, submit.bat. If we look at submit.bat, this is a convenient script to let us use netcat. And again, this will be useful in later steps. We're not going to see this in some of the preliminary steps, but the batch file doesn't help us. We can, however, create a submit script that will help us out on Linux here, so we don't have to keep typing netcat localhost, pipe in the file. So we'll translate this batch file into shell script, and we can just do that at the terminal here by typing in the shell script we want. So we'll call it submit.sh. And we will read from the terminal here until we see the string EOF. It's important to put this in quotes because we're going to use the $sign and we don't want the shells to substitute it. So in any case, this isn't going to be a tutorial on the Unix command line, but if you don't use the Unix command line a lot, just pay attention to those little details here. So this is called a here doc, so essentially anything we type in is just going to go into this submit.sh file, and we will make this a proper shell script by doing shebang bin sh, and then that netcat command works the same under Linux as it does on that Windows executable. The difference is, instead of %1 in the batch file, $1 will be the first parameter that we pass to the shell script. So that's the end of that. So we do our __EOF __ to end the file. And now if we look at our new submit.sh file, you can see we have a shell script which will redirect any file name we pass to it into this netcat command. Great, let's remove the batch file since we don't need that. And let's see what we have now. So concode is a Perl script that we'll use quite a bit. We'll see that later. Create is a shell script, and our new submit is a shell script. Let's make all of those executable so we can run them directly. Okay. A couple other things I like to do just in terms of preliminary steps. We're going to use this create.dadsd.sh script as a convenient way to build the virtual hard drive the emulated hard drive images that our mainframe will run with. And so you can see there's a couple of commands here. We can say create starter. That'll create the starter system volumes as 3330 disks, and so on and so forth. Now, if we look at the DadsDNA command that the script is calling, so DadsDNA is a utility that comes with Hercules to create the emulated DASD or hard drives. It's using DadsDNA-A, and then it provides the file name, the device type, and then just a volume label to get started. I like to use compressed DASD images. On my systems, I don't really notice any performance disadvantage to using them. The compression and decompression routines are fast enough that they're not the long pole in the tent. The actual emulation of the system, I think, tends to be the piece that has more overhead than just having a thread running compression and decompression on, in this case, on this system, a modern Intel Xeon processor. So to do that, we do the -z argument to DadsDNA. So everywhere we see DadsDNA, we want to change it to DadsDNA-Z. I'm using VI as my editor, so it's easy to do that just with a find and replace. So everywhere I see DadsDNA, I want to say DadsDNA-Z. And now you can see throughout this file, we're running DadsDNA-Z. The other nice thing about using CCKD files, compressed CKD files, as opposed to the regular CKD files, is that they don't take up any space on disk until you actually use the space. So we don't have to pre-allocate a bunch of space for drive images if we're not actually going to put that much into the disk. Not a big deal. Hard drive space, I know, is cheap in the modern world. And we're emulating an older system that probably didn't have a lot of hard drive space relative to today's standards. Nonetheless, because I do a lot in VM environments, I don't like to be too willy-nilly with using up the hard drive space, because I like it to be available to make more VMs and do other things. So where are we? We have downloaded all of the files we need. We have made some modifications to the utility scripts. We got rid of everything that was Windows related because we don't want to bring any of that Windows stuff into our nice Linux system here. Some of us probably feel more strongly about that than others. We have our tapes in the tape directory. We've written our submit script. The last thing I think I'll do for these preliminaries, let's go into the conf directory. So all of these .cnf files are the Hercules configuration files with different hardware configs that we're going to use at different stages in the installation instructions. I'm going to open all of these. So vim star.cnf. And we can see, if you're familiar with Hercules, these will look familiar. We have our various device definitions, and we have some Hercules parameters up top. Now I'm just going to make a couple of changes to these. 1900 is the default sysepoch in Hercules. So while some of the defaults it's nice to maybe have explicitly in the file, I don't really feel the need to have that default stated. We're not going to use year offset because we have some patches for the MVS operating system that make it work okay past Y2K. And I'm not going to use a time zone offset in the Hercules configuration files. Eventually, we will set the time zone correctly in MVS itself. So I'm just going to remove the TZ offset from the config file. Now, there are several config files, so I'm just going to write and then go to the next file. And we can see that we can make similar changes. I'm just going to remove those lines. Right, next, and remove those lines. This is pretty optional, but again, like I said, I'll be making some small changes along the way to reflect the way that I just personally like to do things. This is really just personal preference. Okay, is that all? Nope, one more. Sysepoch, TZ, and offset. Yep, that's the end of the files. Okay. So there we are. That covers the preliminaries. We have our Linux system set up with the Hercules emulator. We have all of the prerequisite materials, the distribution tapes, the scripts, and the utility scripts from Jay Mosley. We've already started making some small modifications and customizations. So with that, we will be ready if we look back at the instructions. And again, read the instructions. He walks through, what this folder structure is, where everything belongs. But if you also have watched this video, I think you get a sense of what our base directory looks like. So in the next video, we will get into it. We'll start building the starter system by copying those starter tapes to some DadsD, and we should then be able to boot up our mainframe from the starter system. So stay tuned for part 2. Thanks for watching, and we'll see you next time.